Okay, here's an example of me using my mind via an EPOC headset to control this wheelchair. So we have the EPOC recording my brainwaves, and then those are encoded as directions and key presses to show the motors which way they should push the joystick to go. So I'll go ahead and do a demonstration.
Although I am glad that you took off some homework because, man, mine's not good. It has balance.
Got that part out.
You know that MATLAB one that was due yesterday? I just did. It wasn't even that hard, but that's how the implementation is. I was looking at it.
And that's how it works.
Where was it? I was.
Okay, so this is demonstrating that I can also move left and right.
Yeah, I don't know what we're working on, but
Spin around.
Okay. Making me feel we're gonna be in here.
My computer is not charged at the moment. So now we're going to just show that I can make the motors move without me thinking. So the motors move the joystick. You can see that. Like so. Some of the training that you have to go through to learn how to make the cube move in specific directions, and therefore the wheelchair move in specific directions. So you choose a direction and you can calibrate it to any user who wants to use the chair. And then you just train. I'm training push, so I'll think pushing. Accept the training, and then I'll be able to push the cube like so. And then since we can encode that as a key press on my keyboard, so I have it set to I. The wheelchair is off right now, but if I were to turn on the wheelchair, then anytime I think push, it'll send an I, which will talk to the Arduino and tell the motors which way to turn. The plan was to use some pennies on wires and attach those to our heads, and that would be our input to the Arduino. And then we would use some filters and amplifiers to control the motors. However, we weren't able to get it very accurate, so we upgraded to the EPOC Plus headset, which we borrowed from the neuroscience department. And this is a much more sophisticated headset than pennies are. However, we do hope to construct one in the future. So the way it works, has 14 channels of information, measures mostly the premotor cortex and the frontal lobe. And so there are felt sensors on the electrodes that get past the hair, which are soaked in saline solution, which helps the conductivity. And that's what we use for the EEG aspect. Now, we're going to show you the data that the EEG is picking up. Witness. So on the left, we view the conductivity of the electrodes. The electrodes right now are drying out, but even if there are a few conductivity issues, the program will still work fine. And then this shows the electrical signals over time. If we look at the fast Fourier transform of the data, we see what frequencies are coming out of my brain. So that's the raw data, which is then processed to know when I'm moving in which direction. Yeah, that's good.